Right, so I know it's a mess over here, but that's the mean. That's my magic number, and that's the standard error. So it's going to be 7.9 plus or minus 2 times that guy. And if you do 2 times that guy, you get
0.
Yeah, 0.142, is it?
I have it different because I did the 1.96.
Okay, I'll do that well. 1.96 times 0.057. And
0.11172.
0.11, yeah, 172, that's what I see in front of me. So if you take that away from that, so let's see, 7.9, take away this guy, you get the 7.78. Well, they've got 788, but 7.785 will that's probably caused by using a 2, not using a 1.96. So that's totally what they got. And then if you add these together, right, which is 7.9, add 0.111172, you get at the other extreme 8.011, and they say it's 8.015. So that little discrepancy is caused by a 1.96, I think, instead of a 2. So if we did the same thing with a 2, it would be 7.9 plus or minus 2 of those guys, and 2 times 0.0571 is 0.1142. So that's my new calculation. 7.9 take away 0.1142 gets me 7.785.
Where did you get 0.1142? Because I only got 0.114.
Well, I'm
by doing it by 2.
Oh, I put a 1 there that doesn't exist. I thought I had a 1 there. So I should have got 0.114, which means what? Probably very little, I hope. 7.9 take away 0.
Even if you do it with a 2, it's still 7.786, not 85.
Yeah, you're right.
See, we did it both ways.
Yeah.
We did it with the 1.9. We did it by
If you I can't argue. Yeah, I can't argue with that. It is a 786. Hey, they rounded off funny. That's all I can say. But the answer they gave and the answer I got are so close to each other, they probably would have accepted it. But
okay,
the number
I just wanted to double, triple check because we were confused.
Yeah, the number is so minor. I'll make this up. You know how it's 1.96? It could be 1.964 because they were using a much more accurate version. Do you know how that we have? Do you know how we have 1.645?
Mm-hmm.
They might be using 1.64, or they might be using 1.65, or they might be using 1.6452228. I'm making that number up, but if they were using a slightly different version of that magic number, it's going to make maybe a difference to the third decimal place.
Awesome, thank you. I just didn't know how exact we had to be since neither one of us could.
Yeah, I would. Yeah, I'm assuming that the calculation would have worked with the answer that I gave that was a little bit out, because it has a little bit of wiggle room in answers that it allows. Okay, well, good morning, everyone. I want to tell you something at the end of today, so don't disappear. It's a biggie, hopefully a good thing for you. But let's start our last piece of the puzzle, hypothesis testing. I'm on the wrong section here, so let me load up the right one. There we go. Okay. We're going to look at how do you do a hypothesis test when you want to compare the difference between two populations. All this week we've been doing how do you do, a single proportion hypothesis test, right? How do you prove it's bigger than this, less than that, or not equal to that? So here is the big picture. I want you to imagine that you have two distinctly different populations, right? A population one will have them as self-identified males, and population two as females. And we want to see if we can prove that there's a difference between the two in some way, right? So let's suppose we are interested in the percentage of them who like horror movies, right? And we wonder if there's any difference between the two. There may not be, but let's suppose we're interested in proving that males like horror movies more than females. Let's say that's what I think is true. So what you would do in a world like this, if I wanted to do that, is population one's going to have all the things with the little one on it, and population two is going to have all the things with a little two. Now, I guess I could find every male in the world or every male in America and find out if they like horror movies and you know, do the same with the females. That would be a census and would be extremely difficult and expensive to do, so we won't do it. Instead, I found 150 males, and I found out that 0.4, 40% of them liked horror movies. And I found some females, and there was 200 females in my sample. And I found out that for them, it was 0.35 of them, right? 35% liked horror movies. So raw data, isn't there evidence that males like horror movies more than females? But we already know that couldn't this just be coincidence, just randomness of data? So that's why we need the hypothesis test to decide, is it important enough? Is the data telling us something that's really true? So I'm going to pick that significance level, and I haven't found them not using that. So if you get a question and they don't mention the significance level, you're pretty safe in pretending that they did tell you it was 0.05, because that seems to be the only one they use. So I'm going to test it on this. So we have to set up a null and an alternate. And this time, I want to prove that males is bigger than females. And the null hypothesis is that there is no difference. And the null hypothesis is always the P1 equals the P2, right? Always equal. And in this particular one, I'm trying to prove it's greater than. And in some textbooks, quite a lot of textbooks, that's actually how you write it. But WebAssign and other places, it's not just them, rewrite this in a slightly different way. Mathematically, it's exactly the same. If P1 is equal to P2, isn't saying that the difference between them is 0. Isn't that equivalent? Right? If P1 was equal to P2, isn't this the same thing? And if P1 is bigger than P2, isn't the difference bigger than 0? So it's only cosmetic, because you agree there's no real major difference. But that's the one that we'll use, right? The null hypothesis in every single question. So here's a point in the test for free. The null hypothesis is always going to be P1 take away P2 equals 0, every time. There's not going to be a 0.3 here or a 0.7. It's always going to be equal to 0. And the alternate will be one of 3 possibilities. This is the one we're going for, right? Greater than 0. There's 2 other ones. I'll do them in green. What would be the other 2 situations that you might be wanting to prove? Here I'm trying to prove that the first is bigger than the second, right? What would be the other 2?
Less than different from?
You nailed it. And less than would look like this. And not the same or different, I like your phrase, different than, right? Would be that one. Isn't that very, very like what we did over the last 3 days? right? So there's an awful lot of overlap here, isn't it? You know how you do a hypothesis test when you're testing a single proportion. Now we're expanding it to, well, how do you test two different population proportions at the same time? How do you test for the difference at least? Well, you do it by the difference is 0, the difference is greater than 0 for the alternate, or the alternate is the difference is less than 0, or the alternate is that it's not equal to 0. Now, we would typically do a whole load of calculations, which I'm going to show you once so you know what the calculation looks like, but we're actually going to let Salt do the whole thing, with the exception of they better not have a 16.5, right? So you are going to find the standard error. And it has a formula. And the standard error formula is P1 hat, 1 take away P1 hat over N1, P2 hat, 1 take away P2 hat over N2. Have you seen that formula before? Isn't that the formula that you use to find the confidence interval? Right, it's the same guy. Right. So in this story, we're taking you through the whole number crunching process, as I said, but in general, we are not going to do it this way, right? We're going to let Salt do it because it's much more efficient. So P1 is 0.4. 1 take away P1 is 0.6, and that was the 150 guys you asked. And then for the females, it was 0.35 times a 0.65, and you asked 200 of those. And that guy comes out to be square root of 0.4 times 0.6 divided by 150, add 0.35 times 0.65 divided by 200. And let's say to 3 decimal places. There's your standard error. So far, so good. Set up your null alternate hypothesis, right? Find the standard error. Oh God, I almost forgot the name. I think they call it, do they call it the Z statistic in WebAssign? Right, okay. I'm going to call it the Z score because it's the same thing and I'm used to calling it the Z score. Now, if you want to know what does that look like, here is the formula for it. P1 hat take away P2 hat over the standard error. And P1 hat in this story was 0.4, P2 hat was 0.35, and the standard error was 0.052. That ends up being positive 0.05 divided by 0.052. And I have the answer 0.05 divided by 0.052, and we would get approximately 0.96. And that's our Z score. Now, as I say, I'm doing this one by hand all the way through. So what we get next is the p-value. And the p-value is the probability that you get a Z score greater than that number. And that I have to use Salt. And I'm just going to nip over to Salt and tell you what the answer is. So even although I'm doing this by hand, didn't I eventually get to a place that I can't do this by hand, right? This is something that can only be done through, computer software. So if you bear with me for a few moments, I'll get the answer to what that is so that we can call it good. And the p-value that the calculator gave me was 0.169. And then you finish with your test. And the test is the p-value less than the significance level alpha? Is the p-value 0.169 less than 0.05? And the answer here is no, right? That's not less than, it's bigger than. And when you get that answer, you have a conclusion. And this conclusion, anybody want to tell me what this conclusion would be based on the fact that my p-value is too big? How might we phrase the conclusion?
Could it be something like do not reject the hypothesis?
Yeah, there's a whole load of senses, just like Maggie said. So you would say things like, not enough evidence to reject. They might say H naught, or they might say to reject the null hypothesis. Now that's the lawyer-esque sentence. The English conclusion would be, there's not enough evidence to prove that males like horror movies more than females. That would be a more English interpretation of the same thing. So we've done this test, and I thought guys liked horror movies more than girls do, but I was wrong. The evidence isn't here, right? I haven't been able to prove it. On the other hand, if my p-value had been 0.002, wouldn't I be saying, yeah, I've proved it. Guys do watch horror movies or like horror movies more than females, and I have the evidence to show it. And you could put it in a research paper that social scientists, people who like things like that, would say, I wonder why males like horror movies more than females. And they'd say horrible things about us, like, well, that's because males are just inherently violent, nasty people. And that's why they like horror movies. I don't think they would say that about us. I hope not, anyway. Okay, that is essentially how this whole thing kind of transpires, right? How we make it happen. So what I'm going to show you now are some homework questions. And I'll take you through some of these homework questions. The early ones kind of do the same as the other guys. They don't do the whole thing, right? They just do a little bit at the beginning, you know, like set up the null alternate or something like what's the parameter of interest, you know, those kind of questions. So let's do it this way, it's quicker. Right, are you looking at question 1 from chapter 12? Right, it's one of those sentencey ones, so here it goes. One example of a possible hypothesis of interest is whether or not the proportion who get a particular disease is the same for 2 different age groups. So when they're talking about what is the populations of interest, these are everyone in the age groups. So if I was doing my story, wouldn't the populations be males who watch, who like horror, right? Males and whether they like horror movies, and females if they like horror. If I was doing our Americans, I don't know, Americans spend more time watching TV than British people do. Right? Suppose I was interested in that. And more means more than 4 hours a day or whatever. The populations would be people in America that watch TV against people in UK who watch TV. Right? So you get 2 populations. And it talks about now the parameter of interest. The parameter of interest is there always going to be, in every one of these stories, the difference between the proportions of each group. right? So in my story, it was males who like horror take away females like horror, right? It's a difference between them. And is there any significance between that? And can you see my little P1 minus P2 equals 0? Isn't that what the null hypothesis is when you're comparing two populations? And it's always that for every story, regardless of what that story might be.
How do we write it like that in the homework?
Oh, that's a good question. Right, I'll click on that. Do you see that P1? I'm so glad you did this. You might say, that ain't hard. You write that. Have you noticed that my 1 and 2 are too big? So this is how you get it. You see this button here on func? That one? Click on it, put a 1. Subscript's a fancy name for it. Click on it and put a 2. You see how you type it? Subscript. And subscript is functions, top left hand button, right? That's how you get the P1s and P2s and N1s and any other letter that they get you. Good question. Glad you brought that up. Did you have trouble doing that earlier? No, you know, right. That one's pretty much the same as the one above, so I won't do that. Right, let's look at 3. In each part is the statement a valid null hypothesis, and explain why it is not. In a sample of students, the mean pulse rate for men is equal to the mean pulse rate for women. No, it is not valid. A null hypothesis must be a statement about one or more parameters, not a statistic. Oh, that was a bit pushing it. The average weight of newborn babies. Okay. Yeah, didn't like that question. 4, state the null and alternate hypothesis. Good, I like these. For each of the following potential stories. Do female college students study more on average than male college students? How sexist can you be? That is just not right. Should it have been, do male college students study more than female college students, right? That would have been the right way around. Wait a minute, is that sexist as well? How come it was only sexist when I did the male one first and it wasn't sexist when it was the female first? Is it not sexist? Right, that's me, hurt your poor brain. Okay. The null hypothesis is that they're the same. And the alternate would be that the females study more than the males, which is kind of what they said at the top, isn't it? H0, they're the same. HA, females are more. Oh, I haven't touched on that. And I will now. Can you remember yesterday? I think it was actually on Tuesday we might have done it. When you do a null hypothesis, there's a single-tailed test and there's a two-tailed test. Remember those terms? Single and two-tailed. This one is one-sided, right? One-tailed, one-sided. If it's the first guy is bigger than the second, or the first guy is smaller than the second, that is a one-sided test. And it's a two-sided test when it's a not equal to. You know, they're different in some way. So if the alternate hypothesis is not equal to, then you know you're looking at a two-sided test. And if it's greater than or less than, you know you're looking at a one-sided test. Compared to men who are not bald, are bald men more likely to have heart disease? What a weird way of saying it. So are bald men more likely to have heart disease than non-bald men? So the null hypothesis is that they're equally likely to have heart disease, and the alternate is bald men are more likely than not. You see, we just rearranged the sentence a little. Is that one-sided? Sure. if the answer was, if the alternate had been there's a difference between the groups, but they never said bigger or less, right? They're just different, then it would have been a two-sided. Is there a correlation between height and head circumference? Well, the null hypothesis is that there's no, and the alternative is that there is. And finally got to a question where we're almost halfway through these questions, and we haven't done anything really much except intro. So we are going to go hunting. That's not the one I want. There it is. That's the one I want. During the coronavirus pandemic in the spring of 2020, restrictive measures were enacted to keep people from interacting with each other in public places. Polls asked the following question in the third week of April, and then they asked it later on. So they did a kind of before and after opinion thing. And the question they asked them was, do you think that the current restrictions on how restaurants and stores and other places, are they appropriate, or are they too restrictive, or are they not? So which one did they pick? They had a first group, and the sample was 1,007, and 17% of them, I'm writing this down, 0.17, and that is the first group. So when was that? Was April. So I'll put that up there. And I'll read a little bit further. In May, they conducted the same poll, and in May they went and asked I'm assuming the same number, and it had changed. Oh. Okay, well, I'm there. Are you in there, Chloe? Okay, I lost my screen, and it wasn't Chloe, but I have lost. Whoa, that's weird. I get booted out of website just before I got to the Frid bit where I got the second group. That's annoying. Okay. What question was that? 7?
I think it was 6.
6? It was. You're right. Got question 6 here. And what did we get here? We had a P2 height of 22%. And they tell us everything that we need to know. So it's a negative, that guy, and I'm writing down the other guy, 0, 0, 2, 3. Okay, now let me go back to my white screen then, and that's basically everything they gave me. And now we'll look at the questions. The first question they asked you was to define P1. And P1 ended up being the proportion of people who said, because they were asking people here, they're not restrictive enough. So, so the proportion who said not restrictive. And since it's that one, it was April. And basically, define P2 is the exact same thing, but with May. So in April, 17% says, nah, you should do more. And in May, evidently, it had changed. Now they then go on. Oh, I can show you because they're here. It's quicker than writing it. They then go on and start the hypothesis test. They want to know if the question was, has there been a change? So let's see. The null hypothesis is both things are equal, and the alternate is that they're not equal, because we want to see, is there evidence that it's changed between April and May, right? The P1 hat was that 17%. Remember the 17% in the first April? And that was the May people. And then it says the p-value for the test was this. And the sentence that they wanted you to choose was, the p-value is the probability that you got what you got, right? When there is in fact no difference in the population proportions. And since this p-value is 0.023, and we're comparing against that, the p-value is less than this fella, so there is sufficient evidence to reject the null hypothesis. And our conclusion is then that there is evidence to prove that things have changed between April and May, and this is quite unlikely to have happened by coincidence. And now we're on to question 7, where we get to use SALT to essentially get all those numbers. I'm going to go up now and take those solutions off because they are kind of distracting for the last few questions. So starting at 7, go away. I'm sure I clicked on that. I did. Okay. Right, so I'm going to go through question 7 in essentially the same way that we're going to go through things like question 9, question 10, question 11. Right? They are actually question 12 as well. So if they don't have a SALT button, you still use one anyway. So in a survey was conducted in which it asked college students whether they would return money that they found on a wallet in a street. And the first group is women. And it looks like 86 out of 93 said yes, which is very nice of them. And here they go picking on us again, guys. What did the males end up doing? Well, 56 of them out of 75 said they would do the same. And so we are going to go through an alternative hypothesis test, and we are going to be using a significance level of 0.05, and we are being asked women ask it more, right? So we are trying to do a null hypothesis. And the null hypothesis is going to be P1 minus P2 is 0. All null hypothesis, when it involves two proportions being compared, is always going to be that. And I'm doing the women as P1. I hope they are as well. So we want to see, is there evidence that women, oops. Oh, shooting space, I thought the button I didn't want to hit. There. Got to make sure you don't hit it at the wrong moment. And we want to prove that it's bigger than 0, right? Women bigger than men. Now, all these guys are going to come from SALT. So when I hit this button, that's going to disappear, but I've already written the numbers. So fingers crossed. Oh, you didn't do that, did you? It did. It did. Okay, good. Inferential statistics. Click on this guy. Which one of those do you think we're going to use for our stories?
2 sample proportion?
Nailed it, right? Now, do you notice that you get the question, how many out ofs? Which is good because that's what my numbers are. And in the first one, it was 86 out of 93. And in the second one, it was 56 out of 75. And this is always 0, right? So don't even change that one. and we wanted to prove it was a greater than. Agreed? Okay, so when I hit generate results, that's the Z statistic they want, and that's the p-value that they want. So I'll go down here, find the test statistic, which we would call our Z-score. And that goes here into 2 decimal places. And then the p-value, which is this guy, is to 4 decimal places. So what's that? 7,008. Right, conclusion now. Isn't this p-value less than 0.05? Right, it's a tiny p-value. That means we can make this conclusion. Since the p-value is less than the given significance level, we can reject H naught. This means that there is sufficient evidence to conclude that women would return it more than men. Now, you notice that they phrase this in weird ways. They have all sorts of fail to reject H naught, reject H naught. In this case, reject H naught means good news. H naught's thrown away, we're picking the other guy, right? We're rejecting him, we're picking the other guy. We cool with that one? Right, let's, right, there's one up. Say that again, please.
I hit the submit button and those answers said that they were wrong for HA, the test statistic, and the p-value.
Both of these?
Yeah, mine too.
Okay, let me do something here. I'm going to go in as a student. That way I can test it.
Nice.
Although it won't judge my answers if I don't do it this way. All right, so I'll click in. That was question 6 or 7?
7.
7.
7, okay. Of course, the numbers will change and I will have to make sure I do that.
Mine were the same as yours.
Right, did they give you correct for this piece?
Yes.
Oh, so I don't need to do the P1 thing and I don't need to do the alternate.
The alternative was wrong.
It said what was wrong?
The alternative.
Oh, now the alternate should be P1. Take away P2. So males take away females should be greater than 0, right? And let's do a submit answer. I don't know what you typed, but it says it's right.
We did not equal 2 last time.
Oh, yeah, but yeah, well, we were doing is the women better than the men, so it should have been a greater than, right? So that was that mistake. Now, the test statistic, did you say that these didn't work? Okay,
Yeah.
so let's check that. I'm going to have to change the numbers, of course, because now it's going to be 85 out of 93 for the women, and it's going to be 52 out of 75 for the men. So I'll bring over the salt and I'll change this now to 85 out of 93. Oh, that's good. It's the same number. And then 52 out of 75. Okay, that works. Everything else I think we can keep, generate the results. And so the new data gave me.
Your hypothesis test was at 0.
Well, yeah, this one up here, I just didn't fill it in because I didn't need to. Because
No, in salt, isn't it supposed to be 0.05? No.
No, what you type in, I'll show you what we typed into salt again.
Or the hypothesized difference?
is always 0. If you
Hmm,
put in 0.5, that's why you got that wrong.
yeah,
Right. Now, if you use the numbers that we've got, then these are the two numbers that Salt gave me. And that particular one just rounds off to there. And this particular one, I think, rounds off to there. And so let's do a submit. Everything's fine. It's working. So we'll do one more. No, we won't. We don't have time. Okay. All the questions that come are basically the same story. There are a few things that I do mention, but we have seen them before. And you can always do a read it if you're unsure, and it'll go over some of the things that maybe I didn't spend as much time on. Remember the NP, N1 minus P thing? What number does it need to be bigger than?
0
Not 0.
or
0.05.
Okay. Nope. NP hat and N1 minus P hat. What should they be bigger than? It's called the 10 test, which gives away what they need to be bigger than. They need to be bigger than 10, right? So we have mentioned that. So why am I kind of rushing around? I've been hassled today. It's not your fault. It's just life. But I want to show you something that's kind of important. Let's just close as many windows as I can so I can only worry about one window. Perfect. We got it. Right. So I'm going to move you over to Canvas and explain to you what this mystery is all about. Okay.
oh, the mini test?
Yes, you already noticed it. Have you seen the thing called a mini test?
I
It's
haven't
down-
found the,
Yeah, it's down there. Let me see if I can move some windows around because things are covering up what I want to do. I'm going to go into student view. Are you still seeing Canvas page? Okay. Now, you see this little guy here? Oh, it needs to be done by June the 6th. So let me click on it. Oh, I will publish it. Okay. I'll just tell you what it is. There is a quiz in there. Have you gone in? Is it open yet? Has anybody seen it open? Right, I'll make sure I'll go in and get it home. It's a test, unlimited time, right? So you can go in and go back for it. The points that they give you are so that the college, we're doing a little survey on topics and how they're going, how they're progressing. But for you, you can use, and I suggest strongly that you use Salt and your notes and take as much time as you feel you need to do it to the best of your ability. And once it's graded, once you're finished, and you have to get it done sometime in the next 3-4 days, you will get a bonus for doing it. And the bonus is going to be, you will get 10% added on to any test that you've already done. So if you've got a test that you got an 80, I'll make it a 90 for you, right? So that is what you will get for taking part. So it's a little bonus. Try and do your best, because that's important, because we want good data, right? Statistics is no good. So don't just turn up and say 42, 42, 42, 42. See, I've done the test, I want my 10%, because that wouldn't be fair, right? Because you haven't done anything really. So I don't mind if you get it wrong, that's not the issue. I just want to make sure you do the best.
even when we get it wrong, but we do our best, we still get the 10 points.
Yes, but if you want to get 20%, you have to get them all right. So go for it. Even if you don't get them all right, you'll still get 10%, right? But if you get them all right, I'll give you 20%. Now, once we've got that, I'm going to go and look at your tests, and I'll pick the one that I'm going to add the points to. And the reason I'll do that is I won't do that until all 10 online ones are gone, right? Because it would be easy. All I'll do is find the worst one and give you 20%, right? Because that'll help you bit. Okay. Do you need to know anything else except that it is an online test? And I will open it up shortly, and you will go and look at it and then figure out how you do it and then come back. Right, last name, perfect. And bye-bye.